Good morning, my dear students. Today we are going to learn a very interesting and very important concept for refraction of light at plane surfaces. So that is a lab activity. In this lab activity, our aim is finding the relation between angle of incidence and angle of refraction. So in today's concept we are going to find the relation between angle of incidence and angle of refraction. So for this we will make the preparation of pro circle. So see the preparation of pro circle. So for this preparation of the pro circle, take a wooden plank covered with a white chart. This is the wooden plank I am taking. Wooden plank, and it is covered with white chart. Covered with white chart. Draw two perpendicular lines at the middle of the chart. See, I am drawing two perpendicular lines at the middle of the chart. Mark one line as NM and mark another line as M, which is perpendicular to the MM is perpendicular to the NM. Let the intersecting point be O. So both are intersecting here. Let that intersecting point be O. And here NN represents, so NN represents normal. NN represents normal to the line MM. And MM represents a line drawn along the interface which separates two medium, and above this MM line we can have one medium, and below we will have other medium. We can understand that by following the activity. So MM represents interface of two media. So this MM represents interface of two media. So it is separating the two mediums. Now take a protractor, keep it along the line NN. Now we are taking a protractor and we are keeping that along the line NN, such that its center coincides with O and the diameter coincides with the line NN. So keep the protractor this side and mark the angles from 0 degrees to 90 degrees and again 90 degrees to 0 degrees. And repeat the same on the other side of the line NN also. So keep the same protractor this side also and mark the angles from 0 to 90 degrees and 90 to 0 degrees. So this is see my dear students, this is our protractor. Its diameter coinciding with NN line, its center coinciding with O, and will mark the angles from 0 degrees to 90 degrees and again here to here, that is 0 degrees to 90 degrees. Now the same protractor will keep this side and will measure the angles from 0 to 90 degrees and again 90 to 0 degrees. Now I will take angles. So 10 degrees, 20 degrees, 30 degrees, 40, 50, 60, 70, 80 and 90. Like we'll mark the angles. So this is 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees, 70 degrees, 80 degrees. So like we will mark the angles. So we will get the angles here, 10 degrees, 20 after, 30 degrees, 40 after, 50, 60. So 70 we will have 70 degrees here and we will have 80 degrees here. Like we will mark the angles on all the sides completely. So we will have here so 10, 20, 30, 40, 10, 20, 30, 40, 50, 60. So 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees, 70 degrees, 80 degrees. So 10, 20, 30, 40, 50 degrees, 60, 70, 80. So you will get the angles here. This is 0 now. You will get here 10 degrees, 20 after 30 degrees, 40 after 50, 60. So this is 60 degrees, 70, and we will have the 80 degrees, and here 70 degrees. Like we marked the angles, means we made the, what is that? This is called preparation of pro circle. So one chart we made it. So what is this, my dear students? This is the wooden plank, and it is covered with what? Do you know, my dear students? It is covered with a white chart. Covered with a white chart. And remember that here NN represents what? NN represents the normal and mm represents the interface of two media. Now we will take a semicircular glass slab. So now a semicircular glass slab I am taking. So this is the semicircular glass slab, and keep the semicircular glass slab along the interface line mm. So this glass slab I am keeping here. For our clarity, the second diagram I am drawing, and he has given in the textbook also. So the diameter of this semicircular glass slab coinciding with the interface line mm, and its center coincides with the O, and we have here angles, you know. So this is our interface line MM, and this is our normal NN, and this is the intersecting point. What is this? You know, O. And this is what, you know, students, this is the circular glass slab. So this is a semicircular glass slab, and here we know we have here how many degrees? So we have here 0 degrees, and here we have 90 degrees. Now, so this is then this is 10 degrees, 20, 30, 40, 50, 60, 70, 80 degrees. So here you have 10 degrees, 20 degrees. This part only for our clarity, second diagram we are taking. So, and here we have 30 degrees, 40 degrees, 50 degrees, 60 degrees, 70 degrees, 80 degrees and 90. So this is 10, 20, 30, 40, 50, 60, 70, 80. So like angles we have drawn. Okay. Now, so this is completely, a glass medium. This is the glass, means denser. Glass medium. So this is denser, and this is nothing is there, means what do we have here? Air medium. So this is rarer medium. So air, it is a rarer medium. Now we will take the laser light. So this Mn is the normal, we know, my dear students. Now take a laser light, send it along the normal Nn. So this is the laser light. So laser light, send it along the normal Nn such that it passes from air to glass, air medium to glass medium. So it is going from air to glass and incidenting at the point O. So observe the light ray coming from the other curved surface of this semicircular glass slab. So keep a small black painted wooden plank here along this circular curved surface. This is the circular curved surface now. So to get the spot of the laser light, if you are unable to identify the spot of the laser light, put one small black painted wooden plank here. So we will get a spot on that. We will observe that we will not find any refraction. So we will observe that see, my dear students, what has done here. So now this is our laser light. We are sending that laser light along the normal N. We are sending the laser light along the normal NN, and it is going from air to glass, incidentally at the point O. Means, and we know that we know that for normal incidence angle of incidence I is 0, so angle of refraction also will become 0. So angle of refraction will also becomes 0. Okay, students. So angle I0, angle R becomes 0. Means there is no refraction. But in the air, what is the speed of light, you know, my dear students? 2.99 into 10 power 8 meter second power minus 1. So which is approximately how much you can write it? So you can write it 3 into 10 power 8 meters per second. And this is the glass material. Here we can write 2 into 10 power 8 meter second power minus 1. So this is a medium, this is a glass medium. So going from air to glass, and see, this is our light ray, it is going along the normal. So all angles will measure from the normal. So angle of incidence is 0, angle of refraction is 0. So it will go straight without any deviation. But when going from here to here, speed decreases. Because in the air, speed is approximately 3 into 10 power 8 meter per second. When it is entered into the glass surface, the speed of light will become 2 into 10 power 8 meter per second. Speed decreases, but there is no refraction will takes place. So because for the normal incidence, so whenever normal incidence is taking place, normal incidence means, see, this is our light ray, and this is the light ray, it is coinciding with NN, so its angle of incidence becomes 0. So now send a laser light makes an angle 15 degrees. So send a laser light, so makes an angle 15 degrees with the normal. So this is the normal we know, students. So starting only we have taken NN represents normal. NN represents normal. And MM represents interface of two media. Represents interface of two media. It represents the interface of two media, which is separating two media. Now I am taking the angle of incidence. You can take 15 degrees and identify the refracted light ray from the other curved surface of the semicircular glass slab. To identify that, use a small black painted wooden plank. So take a black painted, a small black painted wooden plank you keep here. You send the laser light. You will get its patch, and see that patch is making how much angle with this normal. Name it as angle of refraction. So and do the experiment. So angle of incidence first I have taken 15 degrees. 15 degrees, 20 degrees, 30 degrees, 40 degrees. So like, and this angle of incidence we should not take more than critical angle. So do this experiment like with different angles, and every time obtain the angle of refraction. Now we'll go for the tabular formula. So tabular formula, take angle of incidence I, angle of refraction I, take the sine angle of incidence and sine angle of refraction, sine angle of refraction, and take the ratio of sine I by sine R every time. Check the ratio of sine I by sine R every time. So I R sin I sin R, and the ratio of sin I by sin R. So first angle of incidence we have taken 15 degrees, next take 20 degrees, take 30 degrees, like repeat this experiment for different angles, but it should not be greater than the critical angle. So critical angle for air and glass is 42 degrees, so it should not be more than 42 degrees. Okay, now 15 degrees angle of incidence, we will get particular angle of refraction. See, this is my laser light. So now, so the same laser light now I took to here, I have taken to here and sending the light ray. So we will observe that it comes out. If I take this angle of incidence, see, this is the incident ray, this is the incident ray, and this is the normal, and this angle we call it as angle of incidence. And this light ray will absorb by keeping a small wooden plank here, and this light ray makes some angle with this normal. We'll take this angle is called, what is this is the normal and this is the observed light ray. So this is the angle of refraction. The only point we should remember is every time light ray should incident at O for any angle, for 10 degrees angle or 20 degrees angle, 30 degrees angle, for any angle the light ray should incident at the point O. For every angle of incidence we will get one angle of refraction. Okay, definitely you will get, so angle of refraction less than angle of incidence only. So take sin I and sin R for every I and R and evaluate the ratio of sin I by sin R. For this angle of incidence I will get one angle of refraction. For that I will take sin I and sin R. I will check this ratio and take another angle of incidence, another angle of refraction will get. Check the ratios of those sin I and sin R and check the ratio. Evaluate the ratio of sin I by sin R every time. So evaluate means calculate. Calculate the ratio of sin I. Calculate the ratio of sin I by sin R. Calculate the ratio of sin I by sin R every I and R. For every I and R you calculate, will obtain that it always remains constant for a given pair of media. So what are the given pair of media? Air and glass. So for this given pair of media, whatever the angle of incidence you will take, you will get one angle of refraction, but the ratio of that sin I by sin r always remains constant, and that ratio always remains constant, and this constant, if I denote with the letter some c, which is indirectly equal to refractive index of this constant indirectly is equal to refractive index of glass with respect to the air medium. Means we are getting the refractive index of glass with respect to air is equal to sin I by sin r, which is always constant. Sin I by sin r, which is always constant, and hence the Snell's law is proved. And here we also got one more conclusion, one more result that, and we are observing. So see here, my dear students, the refractive index of glass by refractive index of air we are taking, that is we are getting sin I by sin r we are getting, which is we are taking as, what do you know students, we are getting as a constant. We are getting as a constant, and if you do the cross multiplication here, so n suffix g into sin r, do the cross multiplication, n suffix g into sin r is equal to n suffix a into sin I. So this is also called Snell's law. This is called Snell's law. This Snell's law is very important throughout the optics lesson. This Snell's law is very important throughout. For a given pair of media, what is the medias here, or what is the mediums here? One medium is air and another medium is glass I am taking. Okay? So one medium is air and another medium I am taking glass. So we are observing that for every angle of incidence, we will get one angle of refraction. So the ratio of that sine angle of incidence by sine angle of refraction always remains constant. So obtaining the relation between angle of incidence and angle of refraction we are telling no. So that ratio you are taking, you are getting every time constant. That constant is nothing but refractive index of the glass with respect to air. Or in the better manner, and see, we have seen in the relative refractive index concept, refractive index of glass with respect to air means refractive index of glass by refractive index of air. So Mg by n suffix a, that is equal to sin I by sin r, that is equal to constant. And while doing the cross multiplication, Ng into sin r is equal to Na into sin I, we got it. This is the original Snell's law. Remember, my dear students, whatever the angle of incidence you have, you will get a particular angle of refraction. You can have any angle of incidence, you will get one particular angle of refraction if these two mediums remains constant. If these two mediums remains constant, you take particular angle of incidence, you will get particular angle of refraction. So now see, this medium will have its own refractive index, This medium will have its own refractive index, absolute refractive index, let it be n suffix A, and this medium has its own refractive index, let it be n suffix G. Refractive index of this I am writing n suffix G. Now take n suffix A into particular angle of incidence, n A into sin I. Refractive index into sin angle of incidence. For this angle of incidence, I get one angle of refraction, that it be R, and this R is in this medium. Then Mg into, so this is angle of refraction, and this is the refractive index, Mg into sin R. This product ratio is same as that of this product ratio. So for particular I, you will get particular R. Then sin I into n suffix A is same as that of sin R into n suffix G, which is named as the original Snell's law. You should remember the Snell's law means in this manner only. So n A into sin I, for one particular medium, you have one refractive index and you will have one angle of incidence. n A into sin I you take, that product is same as that of Ng into sin R you will get. So this is called Snell's law. Otherwise you write, send this Na denominator, Ng by Na you get, that is called sin I by sin R. This we can call Ng by Na is Nga, refractive index of glass with respect to air. Nga is equal to sin I by sin R equal to constant you are getting. So we have seen what is the relation between angle of incidence and angle of refraction. We have got it. Okay students, now and one more conclusion also we are getting. We are taking I, we are getting R. Now take another angle of incidence. See, we are sending the laser light like this. Remember my dear students, remember that it should incident at this point only. This laser light should incident at the point of intersection only, both ends. It should intersect at both. You will get another angle of refraction. Okay students, another angle of refraction you will get. Now, so now what is happening you see? Yeah, every time we find that angle I is greater than angle R. Angle I is greater than angle R. If I take I 30 degrees, I will get its angle of refraction less than 30. If I take I is 20 degrees, I will get angle of refraction less than 20 degrees. Means angle I is greater than angle R. Means angle of incidence is greater than the angle of refraction when light ray travels from angle I is greater than angle R when light travels from denser to rarer medium. So whenever the light ray travels from optically rarer medium, so optically rarer to optically denser medium. If the light ray travels from optically rarer to optically denser, then angle of incidence will get greater than the angle of refraction. From this experiment also we can conclude that. Okay. So angle of incidence is greater than the angle of refraction, and also we can conclude that. So this is the original incident angle. This is the original incident angle. This is the refracted angle. So the light ray has to go like this, but it is bending towards the normal. It is bending towards the normal like this. It is bending this side. Okay students, it is bending this side. That's called angle of refraction. That is called angle of what you are saying. Angle means you can also conclude that when a light ray travels from rarer to denser, light ray travels from rarer to denser, it bends towards the normal. It bends towards the normal. It bends towards the normal at the point of intersection. So, a light ray going from rarer medium to denser medium at the point of intersection, due to changing speeds, this bending effect is taking place. That bending effect we have named as refraction. So, the three important conclusions we have got in this experiment. One is the sin I by sin R ratio always remains constant when these two mediums are constant. That is one result we got. And that is we have just manipulated and we got it as a Snell's law. By doing the cross multiplication, that is we got it as what you know, my dear students. It is named as the Snell's law. Okay, that is. And whenever the light ray going from rarer to denser, the angle of incidence is greater than the angle of refraction we got it. Angle I is greater than angle R. When light ray travels from the rarer to denser. And also we have found that it is bending towards the normal. The process of bending the light ray at the interface of the two media is called refraction. So that also we have seen here. And one more important conclusion we got is, see, this is our normal, this is our line mm, this is our line mm, and this is our normal n. And if we send the light ray along the normal, if we send the light ray along the normal, then angle of incidence is 0, because this is the light ray, angle of incidence is 0, angle of refraction is 0, means it is not suffering any refraction. Here bending does not take place. For normal incidence, angle I is 0, angle R is 0, it does not suffer any refraction. Thank you, my dear students.